Starting.
Good. Hello everyone. There are 9 faces. It's not so. Hello everyone. How are you all? Course has begun. You already see a couple of chat messages. Can it be easy? Can the course be easy? And so on. Quantum is not, it's not easy or tough. It is more very counterintuitive. Probably that is why you are all little bit, there are a lot of things happening in this world which can be only explained using quantum concepts. You all agree? Right? Hello everyone. So you should all agree that quantum concepts, some of them are completely, you need to, even after 3-4 decades of working, there are many things which are not, intuitive wise I cannot answer. I have to see what the experimental data is, how one can explain using the mathematical tools. So this course is mainly how to apply the tools. Okay. So if you understand this course thoroughly, then most of the other books you can start following very easily. Okay. So one student had asked, how easy? It's really tough. What was the statement? Let me read it. And very weak, I want to know which topics in this course can be studied with minimum knowledge and so on. See, there is nothing, there is no gain without putting in efforts. Okay. First of all, you should have a passion. You should like the subject. And if you like and you have a passion, you have to put in hard work. Without putting hard work, there is no easy swimming and getting results in anywhere. So my advice is, there's no easy solution. Okay? If you're not following it, the course is systematically done with a prerequisite, of course. So someone had asked, what is the prerequisite? Well, background is not sufficient to take it up. So I'll ask the TA, Prativa or Purushottam to put in the link. There is a video link. I think Professor Dipan Ghosh has given a set of lectures on wave functions, quantum physics. Maybe looking at it will give you. I did mention when as a trailer for the people to take this course should have at least basic understanding of wave mechanics, wave functions. Otherwise, this course will be little tough. Even though I do browse through the wave functions, I go very fast. So unless you've done that formally, it will be little tough for you. Okay? So you need to have that prerequisite. It's not an easy course. It's not a difficult course. If you really enjoy, I think you should systematically be able to learn from the video lectures, supplemented by assignments. And of course, we are available on portal. You have any specific questions, also live session once a year, once a month you take. So you could post it, you can be present, you can ask your queries. You can ask your queries and so on. Okay?
Someone asks, please explain the wave function.
Okay. So wave function is also an abstract quantity. It's a complex valued quantity, right? What you will be able to find is that if you write any observed quantity, in quantum mechanics. Those observed quantities are obtained by taking the state of a system to be some wave function, and then you evaluate an operator acting on such wave functions. It's a systematic procedure called the expectation value in such states, and they will match with experimental values. Okay? If you want to find what is the average energy, you want to find what is the average position, you want to find what is the average momentum, you need a system to be prepared in a state, and that state in the position space is given by the wave function, position wave function. Okay?
The email it.
Yeah, you can email it on the portal. TAs generally respond. If they still are not clear, it comes to me and I respond also. So this is just to avoid someone wants to join this call. Who's this? Admit?
Admit?
Okay. Okay. So you can ask through the portal email and we will respond, because it's just to avoid the lot of emails which goes into spam or I get to overlook. So if you try to send it to the NPTEL portal, it will definitely get answered. And if TAs do have any specific questions, they do forward it to me and I immediately respond. So that's not an issue. Of course, you can ask questions now and I am here to answer whatever, and every month I am here to answer your questions. And any other questions in the portal will definitely be answered. I am aware of all the questions. Okay? Yeah. I am in a research course and I am doing physics, chemistry or quantum chemistry introductory course. Currently, I can't manage my time. I understand management of time is still, is a challenge, not only to you, to all of us. Okay. So you need to see how to balance, how to prioritize. Each one has their own set of priorities. Okay. And don't stretch too much. If you cannot manage it this semester, this year, you can do it the next year. Okay. Do what you can manage and enjoy. Okay. Should not take everything and make a mess of it, right? That's not allowed. What do you think, Pratibha?
Yeah, that's very true.
Yeah.
What is the best way to approach quantum physics and how to build an in-depth understanding of this subject?
Okay. So this in-depth understanding happens over the years. That's the way I perceive. So don't, if it's the first exposure you are having, just take it as a formal. Go through the math, go through those formalism for simple ideal situations or simple examples. And once you get a feel of it, you yourself will start, questioning, exploring. Can this be done? Somebody has done this little more complicated situation or a system? You start looking at books, and because you've understood the tools of how to apply, that tool learning actually helps you to go and read many of these quantum mechanics books without any scare. You have the courage to understand the notation, you have the courage to work through it and smoothly go through many books. So this is a first course which kind of takes you onto the slope so that you are not scared of going over the course applications later on. So this first exposure is to give you the basic tools. Okay, it's like if you are in a kindergarten, you start learning the alphabets, and then you start using the words and sentences and so on. So in that sense, this is the first exposure where some of them will look counterintuitive, some of them will look unclear why they are doing it. Small things can bother you, but that's a good sign. Okay? It's so different, right? Planck's hypothesis, when he wrote energy is in quanta, when I see the light, electromagnetic waves or electromagnetic light which I am receiving, to see that is in quanta is not visible to me, right? Not visible to any of us. But there are experiments, black body radiation curve, the radiancy versus wavelength, every point matched with the experimental curve, which was based on the Planck's hypothesis theoretically, right? In that sense, a lot of rich information which are stored in nature, we are trying to dig out. Some things can be logically understood, some things are not clear logically, but still it explains the nature. That is what is the essence, which makes the subject more and more. Even after 30 years, I won't say I mastered quantum physics. There are some things I understand, some things I have a feel. I still want to get a feel a little better way. Intuition doesn't help. Tunneling is completely counterintuitive, right? Kinetic energy being negative. If you tell a normal, 11, 12 student, 11th standard, 12th standard student, they will all laugh at us. Kinetic energy, how can it become negative? Right? But that is very important to explain tunneling. And tunnel diodes, everything is constructed based on this, and experimentally they have seen the tunneling current. Right? So those are very counterintuitive. Okay? Yeah.
Standard textbook or reference?
I did mention, I thought in the course.
Video.
Yeah. So Griffiths is the starting level book, and then later on you can take up Sakurai or Schiff. And there are a couple of other reference books, but if you can see Griffiths centered around my video lectures, and then to some extent if you start looking at the modern quantum mechanics by Sakurai, I think you will be able to take off on any other quantum mechanics book after this course.
Okay. How is research in quantum mechanics, and is there any scope in proper theoretical front?
What is this? Okay, so this is a very, everything nowadays, the quantum computing, quantum computers, quantum technology, nanotechnology, name it, they all go into the microscopic regime of short distances, and physics of such atomic scales requires quantum concept. Be it an engineer, be it a physicist, it seems to be that without knowing the quantum concepts, you will not appreciate how things are working in the nanoscale, the nano devices. A lot of things are applying quantum concepts. In that sense, I would think the rest of the next century or next decade will all be, there will be more and more developments in quantum. Of course, there are some subtleties. It's probabilistic. It's not like classical physics where it was deterministic. If you say that you go to a hotel and order an apple juice, you will get an apple juice if you are in classical world. But if you are in the quantum world, you ask for an apple juice, there's only a probability of getting an apple juice. He may bring some other color juice. Okay, so there's nice video on Elegant Universe by Brian Greene, where he talks about quantum cafe, and it's very nice the way he puts these quantum concepts. You should all take a look at it if you have an access to it. Yeah.
Assignment 2, question number 5 had an error, so we will re-evaluate it and post the
So
modified
question assignment 2, question 5
and 3 as well.
And question 3 also has some error, and the re-evaluation will happen, and the marks will be accordingly re-evaluated. So don't worry about it. Yeah.
Someone registered for the exam, but it still shows registered for exam, so will he get the credits?
Okay, so he has to send an email, and you may probably have to forward it to NPTEL office and get it clarified. If you have the registration payment or something, please share that also. Just tell them to share that so that it can be done. Okay. Yeah.
So maybe this person can mail us
Yeah.
separately.
Yeah. So whoever send that
Signature.
message, please send us an email with the registration receipt or something on the online portal, whichever you have received, a screenshot or something, and then we'll take it up with the NPTEL office and make sure that you are able to take the exams. Okay? Yeah.
If sodium light is used in photoelectric effect and diffraction grating experiment, how are time wave and particle aspects are applicable from same source?
See, photoelectric effect requires you to eject electrons, right? And you are trying to look at what is this we are going to look at? We are trying to look at the particle nature of photons, right? Am I right? So you need that is why it's called quantum. So anything electron, we perceive it as a particle. Light, we perceive it as a wave. That is classical aspect. But there are situations where, as I said, the Planck hypothesis is quanta. So there is a quantum aspect of light, where you look at it as if it is like a particle. Okay, that's very counterintuitive. Similarly, electron, we are very happy to say electron is a particle. But to view electron as a wave, how do we check? To check electron as a wave, you have to do diffraction experiment or interference experiments. And if you see an interference pattern, then you know that electron diffraction, electron interference, they show the wave nature of electron. Similarly, the particle nature of light, there are many experiments: Compton scattering, black body radiation, photoelectric effect. This is where you start looking at the quantum nature. I don't think the light of any nature, so it's not sodium light, any wavelength, any light you can take, and experimentally you can plot the photoelectric current and you can show that it validates the particle nature of light. Okay, is that answering your question? So it's not just specifically a sodium light, you can use any light.
This we have already replied, the prerequisites.
Yeah, so this link she will, Pratibha or Purushottam will put it on the portal, where there is basic wave function formalism which has been taught, and it's probably on the NPTEL, and we'll share the link so that you can take a look at the prerequisite elements before you go on to this. You can continue these lectures, but at some point parallelly you start looking at those wave function formalism to get more clarity. Yeah.
Is it a good option for MTech in quantum technology?
See, both an option if you find something is exciting and you feel that you have enough, you have learnt enough background, then you should take it up. Okay? So go by your instincts, what you're passionate about, and of course there are a lot of exciting things in every field, and anybody is really involved and passionate, I'm sure you will all do very good work in that area and have a good interesting results, interesting research happening as an outcome. Okay, so need not be, for one student it might be, a person may be very good at math calculation, one student might have intuition and may be able to see things in a different way. So each one has they have their potential to make an impact. Okay? So I don't generally compare students. I feel that everyone has the potential and you have to take what you enjoy and what you would like to do, and you will come out in flying colors in that area. Okay? Yeah.
If a half circle is drawn, will it represent a wave function?
I don't understand your question. What exactly? So you are trying to say that you want to draw psi of x as if it is a half circle, right? So that's just a functional form which you are trying to give. So I don't even know what, it could be some wave like this, it could be a half circle, any functional form for Ciopex you can draw. Okay.
Can we give intensive opportunity after successfully completing this?
Yeah, so I will talk about this to the concerned NPTEL team and find out how many are allowed and eligible, and I'll try to put it up on the portal. I'll send a message to, forward the message to the TAs and we'll put it up on the portal. I will check it out about this internally. Definitely, if there is an opportunity and if I can manage it, I will definitely allow those number of students to take an exposure, the toppers of the course or something. They have some rules, I have to find out from NPTEL. I'll post it on the Moodle, okay, on the portal, NPTEL portal.
What about Arthur Weiser as a reference book?
Yeah, so Weiser is probably a prerequisite book. You can take it as a prerequisite on the wave function formalisms. That's also a nice book. But what I'm teaching in this course is the Dirac bracket notation. It's a nice, important tool if you want to understand many calculations in an elegant fashion. Okay? So in that sense, the course which I am taking is on Dirac bracket notation. Weiser is like a prerequisite wave function formalism, which you should have learned already before taking this course. If you have not, take a look at this Weiser. And there are also a couple of other books, I think Crane, those are the prerequisite books. There are also NPTEL lectures by, I think, Professor Dipan Ghosh. I have to check and I'll send you the link. Okay? Yeah. Yeah. So how far it has gone in the last 3-4 weeks, Pratibha? What have I finished in the course? On the third assignment, 3 weeks are. So concept wise, time independent, time dependent I've started, or? Yeah, okay.
Practice book for quantum mechanics. Zetterli, I think, has a lot of.
Zetterli, you can send them the reference. Zetterli, I think, is a very fat book.
Yeah.
You can.
Has a lot of practice questions.
Yeah. So don't think you'll have tunneling by putting it as a pillow, but you sit with it and do a lot of worked out examples. I think it's a very nicely collected. Enough set of examples are given there, so you can practice it with that. Okay. How many have joined on the thing? There are about 7 people. That's it. This was announced, right? How can I study the basics if I started to study of quantum mechanics through this course? Please advise. So I've already said all these things to take a look at. So all the questions are answered, looks like. Add a class of problem solving by you. See, the trouble with, NPTEL gets recorded prior. Now we can't do anything by adding new videos to it. Okay, so right now on the live session, if you have any specific set of problems, you can post it prior to the live session and I could try to solve many of them during the live session. This much I can try to do. Okay. But in the NPTEL collection of videos, it is already recorded. Now we can't insert a class of problem solving there at the moment. Okay. Next year I will see whether something can be done. But right now it is already started and I cannot do this.
Google Meet link was not supposed for the participants.
Yeah, so I think this is what NPTEL is saying, that the Google Meet is not for sharing, through the YouTube you can participate. Okay. Due to some academic work in college, I forgot to submit assignment 3. Is there any alternate way to submit it? I think deadlines are very strict. It's all automated. There's nothing can be manually intervened. Okay, so I'm sorry about it. From next assignment onwards, you please submit it on time. And I think there is a 8 out of 12 is
We yes,
you
consider
you,
for the
yeah, so
final
it's not,
scores.
you are not lost much. Okay, so you don't need to worry so much.
The best rate actually.
Yeah, best 8 out of 12 is what is being considered for the assignment evaluations. Ma'am, I want to share some questions, but how to share? Okay, so in the YouTube chatting you cannot. So what you can do is on the portal you can send the picture and share it, and we will respond there, so others also can take a look at the solutions and your questions.
Yes.
Okay. Anything quick where you don't need to share your notes, but you have anything specific that you want me? Meeting link is not shared with the people. That's what I heard from NPTEL office. I don't know. Maybe there's so much of students that they have probably some policy. I really don't know. So let me not argue with them. So if you have anything, you can. Can I refer Griffiths for reference for calling? Excellent. Yeah, yeah. This is the first course where I am centering around Griffiths to start with, and towards middle or later half, you will start seeing that I slowly switch to Sakurai. So after you watch my videos, if you go and look at modern quantum mechanics by Sakurai, you will follow it better. Okay. Till then, you follow Griffiths. Okay. Yeah.
Any other suggestion you want to give them from your side?
No, ideally every student should enjoy what they want to do. What is the course curriculum, ma'am? Best 8 assignments out of 12. What about minors or midsems? No, no, no. The thing is, I'm sure this is announced where assignment evaluation gets done weekly and you get your marks, right? And when they do the final evaluation after your exams have certain weightage, assignments have certain weightage, and all the assignments need not be included. Only the best 8 out of 12 gets into that weightage. So even if you miss one assignment, if you have done 8 of the assignments with, like, let's say full marks, then you may get the full weightage for the assignments. Okay, so in that sense it will be added to your end semester marks, and then you will know what is your total as percentage. Okay, ma'am, in one dimensional box, sudden expansion. Yes. Okay, and see. Yes, here, whatever. Close it.
Blank screen. Right.
Windows. doesn't show. Okay. Where? Okay. So there are two types of expansion, right? One is sudden. Correct me, Pratipha, if I'm making. The other one is adiabatic, right? Adiabatic is if you take a particle in a box, you slowly extend this to L to L prime, which is, you slowly do that. In the sudden, you abruptly change it. Okay? So when you do an abrupt change, what happens to the wave function? Wave function does not get time to change at all, right? It remains like a old function. But in this case, because it's slow adiabatic, the wave function changes. So what exactly you would like to see? These are situations which happens in nature, okay, due to some sudden perturbation, or you can have a slow transformation, that the physics, how things change, how it will have an overlap with the actual ground state wave function. These things will actually be different, right? Here the wave function for this smaller box is different, but the ground state which was there for the bigger box, that will be the state of the system when you go to the smaller box. Then you can resolve that state. It will have a superposition of all possible states in the shrunk box. Okay. In this case, the wave function itself will transform to a new wave function, and then we start looking at various expectation values. So these things happen in nature. Sudden, it's called sudden approximation, adiabatic expansion, and some of these things have been explained in
I have a few slides. Last year also we had this question,
okay,
so
okay.
I had made few slides on
okay.
sudden
So
and
can you
sudden
just share it with them? Yes. Okay. Pratibha will share those slides for you to have little more clarity on this. Okay. Yeah. It will be there. We can just change the slide if required.
No new participants.
Okay. Yeah, other thing is, if this time is not suitable or something, you prefer a convenient time, you can probably mention it on the portal, and we could try to take the majority what time you would prefer and try to fix accordingly the next live session, because that will help. Idea of this live session is that we at least get to answer your queries to the maximum possible extent. Of course, some of them, if we cannot answer, we'll know the questions, we'll put it up on the portal. Okay. So these things can be done if all of you participate. Okay. Okay, there are no further questions. We probably will sign out. And of course, you can put it up. So, a couple of things which they've asked: the link for prerequisite course, then sudden adiabatic slides for them, And this one, the internship issues we should check. What is the rule? And what else?
And about registration, someone had
Registration issues. So maybe you can note it down somewhere and remind me if I overlook something, and then we can. Okay, if there are no further questions, we will sign out now and we'll see you next month. Bye bye. Bye bye.